In this video we're gonna be having a look at very common and very easy stuff. So our first chapter of maths is number system. So let me give you a quick information about number system. So numbers are basically derived from Arabic language and zero. Let's talk about natural number first. Natural numbers. So the natural numbers starts from 1, 2, 3 and so on. Then we have whole, and it is denoted by n. It is denoted by what? It is denoted by n. Now we have another category, that is whole number. Whole number starts from 0, 1, 2, 3 and so on, and these are denoted by W. So let's talk about what's the purpose of natural number and then what's the purpose of whole number. So the natural number is used for counting. For example, you are sitting in a class counting students, so the counting will start from 1, 2, 3, then you're gonna count, right? So the purpose of whole number is for the measurement. Not all these 1, 2, 3, it is all for counting, but talking about this 0, because we know that whole number starts from 0. So the question arises that what's the purpose of this 0? We never asked this question from our teachers, so let me give you an answer. That 0 is for the measurement. 0 is for the measurement. See how? Because when you sketch a number line, we know that number line is basically used in graphs and in your scale. So for the measurement, this 0 is used. The right side of the 0 comes positive values and the left side of the 0 come negative value. So this was the use of 0. Now let's talk about how many decimal numbers do we have. How many decimal numbers do we have? So the number we have with decimal are 10. We have 10 decimal number. How we have 10 decimal number? From 0 onwards 9, we have 1 digit number, and these 1 digit number are known as decimal number. Now let's talk about scientific notation. What is scientific notation? And why do we use that in our life? So for the scientific notation is for concising or to making the value in a short form. For example, this has many zero. If we would like to concise this video, the zeros, the how we would do this? We would count 1, 2, 3, 4, 5. We have 5, rest to the power 5. So this is how the scientific notation works. It is used to concise the values. Now the question arises that why does in your bank checks, these scientific notation are not using? Because here the word says science. So the science, the check are related to accounting subjects. This is a common, and this is the answer. The simple answer is that the word shows science, so it would be coming in science. Does the bank and science relate? No. That is why we do not use that. Now we are coming towards our next category, whole number, natural number. Then we have composite number. Composite number. So the composite number are those numbers those have more than two factors, the numbers who have more factors more than 2. For example, 1 is a prime number, we know. 2 is a prime number as well and even number as well, so it is a middle number. Then 3 is a prime number. Then when it comes to 4, so 4 is a composite number. What do we say, the term used for this? Except then prime numbers, the numbers which have two factors, for example the 4, those are composite number. I hope you got it. Now our next category is rational number. Let me write that in a tabular form, that x such that PQ and PQ belongs to integers. Q does not equal to 0. We'll have a look there. We'll understand this as well. So PQ is a random number. For example, I would say P is 0 and Q is 5. So PQ is an integer. Let me tell you about integers as well. I forgot integer. Integer is the basic number that starts from 0 and that has the value of plus minus 1, plus minus 2. So these are called as integer and this is denoted by Z. Okay. So here P and Q belongs to integers, mean P and Q are the positive, can be positive value and can be the negative value. P and Q can be the positive value and P and Q can be the negative value. So Q, we have the Q at the denominator, the Q cannot be 0. Why this? If 5 upon 0 would be, so this is not a rational number because this will goes to the infinity. You can check. This is the correct, example of this statement, because we have Q at the denominator and P at the numerator. So P does not belongs to Q, because when it will be, so it will become it will go to infinity, right? And let me tell you, this is numerator and that is denominator. Numerators always come inside and denominator comes outside. So the rational numbers are divided into, we can recognize the rational numbers by its two properties, and those properties are terminating and recurring. Recurring also mean repeating. So let's have an example. For example, terminating. 5 is 5 upon 3. Yes, 5 upon 3. So as I told you, this is a numerator and this is a denominator. Numerator always come inside 5. So if we put 0 point and put 30, so 5 6 is 30. So this 0.6 would be the answer. 0 point would be the answer because it is terminating. It is stopping. It is not going. The answer is not repeating or not going. It is terminate. So this is how you can recognize the rational number. Other than, we have another example for for recurring. Now recurring means repetition. For example, if we would divide the value and the answer would be the value answer would be 0.33333, so that is repeating. And recurring means repeating. 333 is repeating, or it can be 0.142 142. So this is repeating, this is recurring. So this is called as rational number. Okay, so rational number can be non-terminating. Are these terminating? Are these stopping? Are these paused? No, they are going, they are continuously moving. So these are non-terminating. No, they are non-terminating. So we can also write that non-terminating and recurring means repeating. Recurring means repeating are also called rational number. Okay. Now we have another category, that is irrational number. Irrational. We have looked by the example as well. So here we're not gonna see the example. I just wanna give you the statement. So irrational number would be non-recurring, non-terminating. Non-recurring and non-terminating are known as irrational number. I hope that is clear. So now we are moving towards our last but not the least, that is complex number. Complex number. First we're gonna see in an order pair that 1 and 3. So this is in what pair? This is an order pair. Order form. Okay? Order form. This part is known as real part and this part is known as imaginary. When these values will be coming out from order pair, so how to recognize them? Let's just add the sign of plus. Then how to recognize what is real and what is imaginary? For suppose. So for that, the math says introduce iota. Okay? Iota will be add with which number, that number will be known as imaginary number. Okay? So if I could tell you, I'll give you a hint that complex number are superset of all, because real number belongs to complex number. I'll tell you. Let's just move on first. So we started from natural number. Natural number is a subset of whole number. Whole number is a subset of integers. Integers is a subset of q, means rational number. I forgot to tell, sorry. Q is for the rational number. Then the subset of q is real number, and the real number subset is complex number that is not equal to 0. So this is the whole statement. These are the subset. So who is the superset? Who is the master of all? Complex number would be. And if I could write in the superset form, so first would be the complex number is the superset of real number. Real number is the superset of rational number, and rational number would be the superset of, this is the sign of superset by the way, z integers. This superset of whole numbers, w that is denoted by, and whole number is the superset of natural numbers. I hope you got it. Now we are gonna do the operation in complex number. Operation, we have certain formula, we have two formula. We're gonna see operation in complex number. Okay, so the first formula, it's very common, addition. The addition in the complex number is very common, so we usually add the real part and the imaginary part. 1 plus 2 is equal to 1 plus 2. Then we have 3 plus 3. Imaginary, real to real, imaginary to imaginary. So the answer would be 3 and 6. This would be the answer. Same we're gonna do with the minus. Now we have how to divide then. So for the category of multiply, I'm gonna see multiply first. For the category of multiply, we have a formula. Let's see the formula first. AC minus BD and AD plus BC. Get it? So let's just prove that. So yeah, 3, 4, we have this order pair, and we have 1 and 2. Let's just solve this. So we're gonna write the value. First we have the value of A is 3, value of B is 4, value of C is 1, and the value of D we have 2. According to the formula, we're gonna put the values. So the value of A we have 3, and the value of C is 1. Then we have the value of B is 4. Then we have the value of D is 2. I'm sorry for this. Wait. Okay. So the value of then A we have 3. Then we have D value have 2. Then we have the value of B, we have 4. And we have the value of C is 1. So 3 ones are 3, 4 twos are 8. Then we have to add 3 twos are 6, 4 ones are 4. Then we do the sum and the minus, we minus them. So we have minus 5 and we have 10 in the order pair. So this is how would be the answer. Now for division, we have another formula, and that is in a very again, AB divide by CD, that is equal to AC plus BD upon C square plus D square. Then BC minus AD upon C square plus D square. This is quite simple formula. So our last topic is remaining to be done. If I could ask you, can you please say this value is equal to iota? Iota is a Greek letter, by the way. It is used for, as I told you, to recognize the imaginary. Can you say this? This is iota. Yes, this is equal to iota. Let's see. We could not add iota with 0, but we will add iota with 1. So if you multiply 1 iota, 1 iota ones iota. So is this not equal to iota? Yes, exactly. This is equal to iota. So we can also say this 0, 1 is equal to iota as well. If I could add iota square and iota plus iota multiplied by iota and 0, 1, this is also correct. Now we have that another condition, that is iota is imaginary square of imaginary is converted into real number. Let's see how. For example, 4, we have the square 2 square. Okay, 2 2s are 4. So what's the value of iota? Iota value is -1. So if we 4 multiplied by -1 is equal to -4. So where is iota? Because square value is converted into real value. Yes, and that is true. So the value of iota square is -1. Got it? It's a constant value.